This is problem number 6 of the 2012 AP Calculus exam. The particle moves along the x-axis. The velocity of the particle at time t is 6t minus t squared. What is the total distance traveled by the particle from the time t equals 0 to the time t equals 3? Well, the first thing I want to know is, does this particle change direction on that time interval? And we can look at the velocity function to determine that and make sure that it does not before we proceed. So let's go ahead and look. If we have the velocity of t is equal to 6t minus t squared, and we set that velocity equal to 0, we find out at what point in time the velocity is at rest and or about to change direction. So we can look at that velocity is 6t minus t squared. Let's factor out a value of t, and we get 6 minus t times the t equals 0, which means at the time t equals 0 and at the time t equals 6, this particle is at rest. Well, we can look at that function a little bit, that velocity function, and at 0 and at 6, we have this parabola that's concave down. And we notice the velocity function is greater than 0 on the time interval from 0 to 6. It is equal to 0 at the value when the time t equals 6, and it is less than 0 when the time is greater than 6. So we see a sign change there, and so the particle is changing direction at the time t equals 6. But that doesn't affect our problem because we're looking only at the time from t equals 0 to the time t equals 3. So we can proceed as normal with the setup using x sub b minus x sub a, the position at time t equals b, minus the position at time t equals a, as being equal to the integral from a to b of the derivative of my position function, x prime of t dt. And we know that the derivative of the position is velocity, so I can rewrite this as x of b minus x of a as the integral from a to b of the velocity function with respect to time. Now we're given the limits of integration. So this will be from 0 to 3. We're given the velocity function, 6t minus t squared. And that means we'll have the position at time t equals 3 minus the position at time t equals 0 as being equal to that integral from 0 to 3 of 6t minus t squared. Okay, let's go ahead and solve. We're going to get 6t squared divided by 2 minus t cubed divided by 3, evaluated from 0 to 3. And if we simplify, we get 3t squared minus t cubed divided by 3, evaluated from 0 to 3. And substituting in the 3 and the 0, we'll get 3 times 3 squared minus 3 cubed divided by 3, minus 3 times 0 squared minus 0 cubed divided by 3, which will give us 27 minus, and 3 cubed is 27. 27 divided by 3 is 9, so we get 27 minus 9. And 3 times 0 squared is 0, minus 0 cubed divided by 3 is still 0. And so we get 27 minus 9, which is 18. And that's going to be our total distance traveled. And so that answer then would be letter D.